Here, we are going to study certain angles and their interrelationship, which is important while observing the sun. So we'll start with Earth. This is Earth's center. Then show Earth's axis. And as you know, the Earth's axis points towards the pole star. Then we'll show the equator and we'll take an arbitrary point on Earth's surface. Okay. So this is some little town in which our observer lives. Okay. We'll show the local ground, okay, which is nothing but a plane tangent to Earth's surface. Okay. So although Earth is curved, to the observer, it will seem to be a flat ground. So let us show the observer and his little home. Then we are going to provide the observer with an instrument to measure angles, so of course a protractor. We are going to nail that protractor at the center so it can rotate around that center. Then we are going to tie a string to this nail and hang a weight by it. We call such arrangement as a plumb line, and that gives us the local vertical. It will be hanging down like now. Here the observer knows his latitude. Okay, so we can show the latitude of that particular town. So latitude is nothing but the angle made by that place at the center of Earth with the plane of equator. Okay, so that's the latitude. Then the observer is going to rotate the protractor. So we'll take this protractor, rotate about this nail so that this goes around, and you'll keep rotating it until the angle made by this plumb line, okay, is equal to the latitude angle. Okay, so that's the rotation is going to give. And once that is done, something interesting happens. This 90-degree line then becomes parallel to the axis, and that too will start pointing to the pole star. Secondly, this line, the 0 and 180-degree line, is perpendicular to the 90-degree line, so that will start pointing in a perpendicular direction. And what is that? That is nothing but the plane of Earth's equator. So let us show that as well. So here, and then of course we'll show what is the most important object in this experiment, and that is the sun itself. Okay, the object of our interest. Then we are going to take all these things and we are going to plot them in a more convenient orientation. So instead of this ground being inclined like this, we will show it as horizontal. Okay, so this is the ground, this is our observer and his little home, and this is the protractor which he has reoriented so that the plumb line over there makes the angle equal to his latitude. Okay, so this is the latitude angle I have shown here, 5 degrees. And if you extend this vertical line, then these two angles are going to be opposite angles and therefore equal. Then let us show the local horizontal here, which is parallel to the ground. So this line ultimately goes and meets the horizon there. We'll show the pole star, which as you know is pointed to by the 90-degree line. This is that line. And now let us show this line, which is parallel to Earth's equator. But we are going to imagine that Earth's equator is scaled up so that it becomes bigger and bigger and bigger and ultimately lies in the sky. Okay, so on the celestial dome or celestial sphere. Okay, so then it is called as celestial equator. So this line is in the plane of celestial equator. Okay, and finally, of course, the sun itself. So the sun is at this point. Now this observation is made not at any arbitrary time, any time of the day, but it is made at the local noon, or when it is 12 o'clock in the local time. What's the meaning of that? That is the time when the sun appears at the highest point in the sky. Okay? So right from the sunrise, the sun is rising in the sky, but at one point it stops rising and starts descending down. Okay? That is the point we are taking. That is the highest point. The plane, the vertical plane that passes through that point is called meridian, and it's a north-south plane. Okay? So sun is at meridian. That's another way of saying it. Okay, so now we'll start measuring angles. First angle that we show here is called declination of the sun. So what is declination? Declination is how high the sun is or how far the sun is from the celestial equator, okay, at this local noon. So this angle shown in orange, or this angle, okay, same, they are again opposite angles, is called delta. Then we are going to plot another angle, okay, from the horizon up to the direction of the sun, and this is how high the sun is in the sky. Okay? So this is called its altitude. And then we are going to take the angle between these two lines, okay, the sun's direction and this vertical. How much will that be? Well, this whole angle is our latitude, and part of this part is the declination. So this part, the remaining part, must be the difference of the two. So let's mark that. So here, this green angle is latitude minus declination, okay, phi minus delta degrees. Okay. And we are all set for formulating the relationship. Well, from vertical, if you start, go along this green line, it will bring you to this line. And from that line, if you keep further going down, okay, along this blue angle, it will take you to the horizontal line. So from vertical to horizontal, that is 90 degrees. That means this green angle and this blue angle must add up to 90 degrees. And that's the formula, that's the equation we were looking for. So we are saying, if you take this whole angle 90 degrees from vertical to horizontal, 90, and if you subtract this difference, okay, this 5 degree minus delta, okay, latitude minus declination, if you subtract it from there, then what remains is the altitude of the sun, okay, at the meridian. Okay. So that's our formula. Of course, in this formula, what's the unknown? That depends on the situation. Sometimes you may measure the altitude, okay, you may know latitude, and then you are trying to find the declination of the sun, okay, how far the sun is above the celestial equator on that particular day. Thank you.